Peace be upon you, dear student of a third year prep. Today we will continue to talk about our favorite subject and learn basic concepts and basic syllabus in the last chapter in algebra. We will continue to talk about the random experiment and sample space. We learned previous years, and we will talk about the last chapter in statistics. Let us to see probability. The random experiment. It's an experiment in which we can specify all its possible outcomes before performing it, but we cannot determine which outcome will occur certainly. The sample space is a set of all possible outcomes of a random experiment, and we do not buy S. The event. It's a subset from a sample space of any random experiment. The event, it's a subset from sample space of any random experiment. The probability of occurrence of the event. To get the probability of any event like A from sample space S is P of A equals square fraction like this, number of elements of A divided by number of elements of the sample space S. It means that P of A equals N of A divided by N of S. For example, a regular die is tossed once, randomly. Then we will get a sample space like X equals 1, 2, 3, 4, 5, and 6. If we want to get an event of getting an even number, we will get the even number in our sample space 2, 4, and 6. If we want to get another event like the event of getting a prime number, show the prime number in our sample space S, we will get 2, 3, and 5. These two events are called possible events. The event of having a number greater than 6. If we want to search about any number greater than 6, we don't find any number. It means that the event of getting a number greater than 6 equals 5. It means that empty set or null set. This event called impossible event. In the experiment of rolling a fair die once and observing the number appears on the upper face, if A is the event of getting an even number, B an event of getting a prime number, C perfect square number. Find B of A, P of B, P of C. A is an even number, we will get 2, 4, and 6. It means that P of A equals a number of elements inside A 3 divided by number of elements inside the sample space equals 6, and a simplest form equals 1 over 2. B equals 2 and 3 and 5. These are the odd prime numbers in our sample space. To get its probability, P of B equals number of elements inside B equals 3 divided by number of elements inside our sample space equals 6, and a simplest form P of B equals 1 over 2. Perfect square number, it means that we will search for any number has a square root, get us an integer number or a rational number. It means that C equals 1 and 4. P of C equals number of elements inside C equals 2 elements divided by number of elements inside our sample space 6, and a simplest form equals 1 over 3. Operations on events. The intersection. A and B are two events from the sample space S. If we draw two ovals, one of them A and the other B, search for the intersecting parts of our two events, and it means that the shadow region represents our intersection. If A and B two events, and A is shadow rigid, means A and B. And it means that the two events A and B occurs together. So the intersection of the two events A and B denoted by A intersecting B. لو خدنا بالنا كده هتلاقي الشهادة الزور دي عبارة عن region between the two events together. For example, a regular die is tossed once randomly. Write the sample space. Then write the following events. First event of getting an even number. B, event of getting an odd number. C, the event of getting a prime even number, prime and even number. Then find the probability of, first, occurrence of the two events A and B together. Second, occurrence of the two events A and B together. S. Our sample space S equals 1, 2, 3, 2, 6. The event of getting an even number A equals 2, 4, and 6. And also the event of getting an odd number B equals 1, 3, and 5. Last one, the event of getting a prime number and even just 2. He wants us to get P of A intersecting B. Occurrence of A and B together, it means that we will want to get P of A intersecting B. Search for any common elements between A and B. There is no any element between A and B. It means that P of A intersecting B equals 0. And also he wants us to get the probability of getting A and C together. Search for any intersect between A and C. We will get the event A include 2 and also include 2. It means that P of A intersect C, just one element from the 6 elements. It means that P of A intersecting C equals 1 over 6. The union between the two events A and B. If A and B are two events from the sample space S, like two ovals, one of them A and the other B, and it means that the occurrence of the two events A or B, or both, at least one of them. So the union between the two events A and B is denoted by A union B. And A and B are two events from the sample space S. For example, 9 identical cards numbered from 1 to 9. A card chosen randomly. Write the sample space, then write the following events. First, event A of getting a card having an even number. Event B of getting a card having a number divisible by 3. Event C is an event of getting a number prime greater than 5. C of getting prime number greater than 5. Then find the probability of occurrence of the two events A or B. 2. Occurrence of the two events A or C. Our sample space S equals 1, 2, 3, 4, 5, 6, 7, 8, and 9. The event A and even numbers 2, 4, 6, and 8. And also B, a number divisible by 3, we will get 3, 6, and 9. And the event C represent 2, any prime number greater than 5, just 7. If we want to get A union B, the event of occurrence A or B, it means that we will get A union B. To get the union between the two events together, we will write each element inside A and B without repeat any element. A union B equals 2, 3, 4, 6, 8, and 9. And also A union C equals 2, 3, 4, 6, and 8. And also we will write the element 7 as the event C. If we want to get A union C, number of elements inside A union C equals 5 elements. Inside 9 in S, we will get P of A union C equals 5 over 9. Sample space S is 1, 2, 3, 4, 5, 6, 7, and 8, 9. The event A equals 2, 4, 6, and 8. The event B equals 2, 6, 3, 6, and 9. The number divisible by 3, 3, 6, and 9. And the event C, we will search for a prime number greater than 5, just 7. He wants us to get the event of occurrence A or B. This means that we will search for the elements inside A and B without repeating any elements. We will write 2, 4, 6, and 8, and also 9. The event of occurrence A and C together, we will write A and C, 2, 4, 6, and 8, and also 7. To get the probability of A union B, we will count numbers of elements inside A union B, 1, 2, 3, 4, 5, 6, divided by number of elements inside our sample space, 9, 6 over 9 equals 2/3. And also to get B of A union C, we will count how many numbers inside, how many elements inside A union C, 1, 2, 3, 4, 5, 5 over 9 number of sample space S. A union C, 2, 4, 6, 8, B of A union C, 5 over 9. Search for P of A plus P of B minus P of A intersecting P, and P of A union B. What will you deduce? A union C equals 5 over 9. P of A plus P of B minus P of A intersecting B equals 4 over 9 plus 3 over 9 minus 1 over 9 equals 6 over 9 equals 2/3. What does it mean? It means that P of A union B equals P of A plus P of B minus P of A intersecting B. This is our rule. If A and B are two mutually exclusive events, then P of A union B equals P of A and P plus P of B. Two mutually exclusive events mean that two events hasn't any intersect between them. If A and B are two events in our sample space S of a random experiment, complete. P of A equals half, P of A equals 2/3, P of A intersecting B equals 1/3, then P of A union B equals P of A union B equals P of A plus P of B minus P of A intersecting P. It means that P of A union B equals 1 over 2 plus 2/3 minus 1/3 equals 5 over 6. If P of A equals 3 over 8, P of B equals half, P of A union B equals 5 over 8, then P of A intersecting B equals, we know that P of A plus P of B minus P of A intersecting B equals P of A union B. By substituting, P of A intersecting B equals 3 over 8 plus 1 over 2 minus 5 over 8, our union, equals 2 over 8, 1/4. Another example, if A equals, P of A equals 1 over 2, P of B equals 1/3, find P of A union B in the following cases. First, if our intersect equals 1 over 8, this means that P of A intersecting B equals 1 over 8. Number 2, if A and B are two mutually exclusive events. What's meant by exclusive events? It means that our intersect equals phi, and the probability of our intersect equals 0. P of A intersecting B equals 1 over 8, and we know that P of A union B equals P of A plus P of B minus P of A intersecting B. By substitute, P of A equals 1 over 8, 1 over 2, P of B equals 1/3, minus our intersect equals 1 over 8, equals 17 over 24. The second condition, the two events are two mutually exclusive events. It means that our intersect equals phi, and its probability equals 0. It means that P of A union B just equals P of A plus P of B. P of A equals 1/3, P of A equals 1/2, and P of A equals 1/3. This means that P of A union B equals 5/6. Complementary event. If S is a universal set and A subset from S, then the complementary S of a set A denoted by A complete or A dash. Let us to see if we have universal set like S or U. Observe this oval represent to our event A, and all of outside A represent to the complement of A or A dash or A of A complete. So that A union A complete equals all our sample space. And A intersect of A complete equals phi. There is no any element between the two events together, A and A complete, where A belongs to our sample space S. And also A complete union belongs to or subset from our sample space S. If the sample space S equals 0, 1, 2, 3, 4, 5, 6, and 7, and if A equals 1, 3, 5, what does it mean? It means that if we want to get A complete, we will get the remainder parts inside our sample space. A 1, 3, 5, and the remainder 0, 2, 4, 6, and 7. Difference between the two events. If A and B are two events of a sample space of a random experiment S, then A difference B means occurrence of A and non-occurrence of B. Or we can say the occurrence of A only. If we want to get A only, it means that we will get A difference B. So we have two ovals like A and B, the event A, the event B. Between them, our intersect, A intersecting B. If we will get the elements inside A and doesn't belong to B, it means that we will get A difference B. And also our space B difference A, it means that we will search for the elements inside B and doesn't belong to our set or event A. P of A difference B equals the oval A without the intersection. It means that P of A difference B equals P of A minus P of A intersecting B. For example, a classroom of 30 students. 18 of them like math, 15 of them like English, and 8 of them like both. A student is chosen randomly. Calculate the probability that the chosen students at first like math, 2 doesn't like math, 3 like English, 4 like both of them, like math only. Our classroom S includes the event of A represent to number of students like math, and the event B represent to the students like English. At first, we must write eight students between the two intersect between the two events A and B. How many students like math? 18. 8 inside the intersection between the two events together, and 10 outside. How many students like English? 15. One of them 8 between the two events together, and 7 outside. If we count number of students like math or English, 10 plus 8 plus 7 all equals 25. Our classroom includes 30 students. It means that we have remainder 15 students outside like math or English. Each element represents to a certain event. If we want to represent to the 10 students, what's meant by 10 students like this? It means that number of students like math only. It means that A difference B. If we want to represent to 8 students, what's meant by 8 students in our ovals. It means that number of students like A and B together, or like A intersect B. Number of students like math and English, 8. What's it meant by 7? It means that number of students like English only. If we want to get number of students doesn't like any one of them, 15. Outside A or B. If we want to get number of students doesn't like math out of our oval, out of 10 and 8. It means that doesn't like math represent to 7 and 15. If we want to get number of students doesn't like English, it means that we will search for the numbers outside the oval B. Represent to 10 students inside the math, and outside of our ovals, 15. If we want to get anyone like math or English, we will get numbers 10 and 8 and 7. 10 like math only. 8 like both of them. 7 like English only. All equals A union B. Outside 15 doesn't like math or English. It means that if we want to get number of N's like math, their numbers 18 divided by 40. It means that we will get the number of students inside the oval of A only. Like math, yellow part. Like English, purple part. P of like math, 18 over 40. In SMS form equals 9 over 20. Doesn't like math, we will get the remainder oval, remainder students outside math. Or we will complete our event. 1 minus 9 over 20 equals, in SMS form, 11 over 20. If we want to get the students like English, we will get count number of elements inside our oval B, 15 over 40. In SMS form equals 3 over 8. If we want to get P of like both, it means that we will get the elements inside A and B together. The position of the intersection between the two events together. If both of them, it means that we will get the intersection. 8 over 40 equals 1 over 5. يبقى بالراحة كده واحدة واحدة كده لو خدنا مع بعض بقى كده union بقت 10 plus 8 plus 7 over 40. Intersect just 8 over 40. If I want to get P of A, يبقى 10 plus 8 over 40. If I want to get P of B, we will get A plus 7 over 40. I don't like to get A outside A, 7 plus 15 over 40. I don't like to get B, it means that we will get outside B, 10 plus 15 divided by 40. If I search for anybody doesn't like math or English, I will get 15 over 40 outside the two ovals A and B. I can get the students which like just one subject. Just one subject. طب اللي بيحب one subject, just one, تقول مثلا 10 students inside math or 7 students inside English. يعني we will get number of elements 10 plus 7 divided by 40. وبكده ممكن الشكل دوت يحل لنا مشكلة intersect, union or حتى difference. لو لاحظنا كده مع بعض ممكن نشتغل عن طريق الشبه على طول ناخد النمبرز، او ممكن نشتغل عن طريق الرولز اللي عندنا. P of A equals 18 over 40. P of A complete 1 minus P of A. Like English, P of B equals 15 over 40. Don't like math, يبقى we will don't like English, we will complete our event 3 over 8. Both يبقى انا بدور على intersect between them اللي هي 8 over 40 equals 1 over 5 in a simplest form. The probability of the student choosing like math only, it means that 18 over 40 divided by minus 8 over 40. يبقى P of A minus the intersection between the two events. 18 over 40 minus 8 over 40 equals 10 over 40 equals 1/4. P of the choosing students like English only, it means that we will get P of B in difference A. P of B equals 15 over 40 minus the intersection between the two events together, 8 over 40. equals in SMS form 7/40. And I hope you continue. Thanks and goodbye.